Hello and welcome to today's webinar. This is Mark Plantier of Enercon Industries, and we'd like to thank you for attending the presentation on 5 ways to grow your business with plasma and flame surface treating projects. If you have any questions during the webinar, please use the GoToWebinar question tool. You may submit a question at any time during the presentation, and we'll reserve time at the end to answer as many questions as we can. Please note this presentation is being recorded, and you'll be able to access both the recording and presentation slides once they are available online, usually within 24 hours. In today's presentation, we'll share which markets are driving the need for surface treating integration. We'll provide insights on the applications requiring integration and how Enercon plasma and flame technologies are used. We'll also look at how Enercon's integration-ready equipment and support eliminate project pain points for integrators, reducing cost and ensuring success. And we'll share information on how your company can become active in these markets. Today, we are fortunate to have Wilson Lee, an expert in the field of adhesion, surface treatment, and surface analysis. Wilson is Enercon's Business Development Director and has extensive experience in plasma and flame surface treating in assembly and decorating applications over a wide variety of industries, including automotive, aerospace, battery, construction, consumer goods, medical, plastics, window and doors. He has also authored numerous technical articles and is a frequent presenter at industry associations and events. In fact, tomorrow, Wilson is presenting at the Plastics Product Decorating Summit in Charlotte, North Carolina. Wilson earned his electrical engineering degree and MBA from Clemson University. Wilson, I'll turn it over to you.
All right, thank you. So again, we're going to talk about integration today, and I'll probably say this a few times. We do a lot of applications. We have a lot of testing that runs, but there's only so much Enercon can do on the integration side. So we have to have partners in the integrating world to help us satisfy the needs of our customers. So we're going to start with some of the hot markets in integrating, and obviously the biggest one for plasma probably every year is automotive. We do a lot of automotive. We're going to show a video later of an application similar to that picture that you're seeing there. Foam in place gaskets is the one that we're featuring today, which is a very common application where we're pre-treating with plasma right before the foam in place gasket goes in place. This is an engine block application we're talking about, but there's also assembly applications, decorating applications, sealing applications, window and door or window applications, door seal applications, sunroof applications. So obviously the automotive industry is used to dealing with integrators on a daily basis. So it is not hard to find or it's not hard to get the automotive industry to look at integration as a solution. But in some of the other applications that we talk about with customers that are not in the automotive industry, dealing with an integrator is a little bit more challenging, and they don't do it every day, so they need more help with that. So we can go to the next slide. Here is the again the hot market. Mark, is this where we show the video for this? I apologize.
Yep, I will get that video started. Please note that when we do play videos during the presentation, the audio for the video can be heard through your computer speakers. I'm going to call that video up now.
Okay, so now let's show you a perfect example of an automotive integrated part with the 6-axis robot. We're going to be using a blown ion 125, and the end result here is going to be a foam in place gasket. So there's a couple of shots here of the blown ion 125 going around the edge where the gasket is eventually going to go. The speed here is probably a little slow. We probably could have gone a little bit faster and gotten the same results. But if you're definitely trying to clean the surface, you might want to go a tad slower, especially if you have the cycle time. So anyway, we're going to watch the 125, and then after it's complete, you'll see the foam in place gasket being dispensed onto the surface. Here you can see the 125 actually cleaning that surface a bit. And now we're putting the gasket on. So the gasket goes around the treated line. Then you're going to put the top piece on. And then after you do that, you're going to bolt it down. Now we don't actually see that in this video, but again, this is the gasket being put in place. What you have here is another type of application, very similar. It's going to be using a blown ion 125 again. This time it's going to be using a 45-degree nozzle. So this allows you to treat at a slight angle. And so with a vertical spot like this, like you're treating in this video, you will be able to get that and do the same thing as you did with the 125 on that flat surface. This again will be a foam in place gasket. Now we're not actually going to show the foam in place this time. We're just showing the capabilities of a 45-degree nozzle. Next, we're going to see the blown ion 500. Now for a larger area, say a 2-inch wide area, this is going to be much faster. You could do this with a 125 and make multiple passes, but if you need to clean this again in a relatively short cycle time and get it ready for the bond, you can do it with a 500 and save some time. We also have a 250 and a 750, and those are just different size nozzles that we can use again to treat wider areas. And one more time, the cleaning effect and activation using the 500 on the flat surface. All right, thank you, Mark. So the reason we wanted to show that video is what's going to happen in the next slide. This was a study that was done by one of the automotive manufacturers that we work with, and they were doing an oil leak comparison that started back in 2022. And you can see the relatively stark difference between warranty repairs, in this case, of when you did plasma prior to the foam in place gasket, and then when you did not use a plasma prior to the foam in place gasket. And the variability on the without plasma side is common because anytime you have somebody, what they were doing prior to that was cleaning the surface with a solvent of some sort. I don't know that they were priming the surface at all, but they were just cleaning the surface. And anytime you clean something by hand, you're going to have variability. So you can see some spikes in there where obviously the cleaning they were doing on other lines was not adequate. And of course, it's pretty consistent when you see the plasma. And so this was a very big promotion for us. This was promoted inside the particular company that ran this for us all the way up to their senior management. And they're looking more and more ways now to use plasma. But going back to this presentation that we're going through, that type of integration with the 6-axis robot that's just something that's beyond the capability that Enercon can provide easily. We can do some conveyor type applications and some small, simpler robotic applications. But when you get to something more complicated like a 6-axis robot, that's where we need partners on the integration side. Another area where a lot of integration is used is window and door applications. We do a lot of these applications. There will generally be a robotic feature that is treating the inside surface of say the plastic component of a window. They'll treat that with a blown ion 125 generally, and then go back and put a glue line around that. There's also a lot of door frames and doors and garage doors and any type of door that you can think of, really, which we use conveyors generally with those, and conveyors along with flame systems to treat wider areas and multidimensional areas. And this is the best way to do that. So some of this we can do internally. Most of the time, it's in our best interest to work with a partner on this in order to help the customer meet his needs, just so that we can make sure the cycle times are correct, and make sure that everything's coordinated together and the flame system or the plasma is coordinated with the adhesive or the coating that's going on top. So this is another application where integration is important. This is a relatively new thing in the industry, and that is direct to print. And that is, of course, just where a lot of companies are moving away from labeling. Labeling is a relatively simple application for us. We can use a blown arc or a blown ion or a flame system. And then it can go directly into a label that's usually spun on in some form or fashion. But a lot of companies are going to this direct to print. And that means that they can easily do a lot of things. It helps them if they need to change that label. They don't have millions of dollars or hundreds of thousands of dollars of label stock they need to work through, or that they need to trash, so they can just change something or some wording or some logo on the label. They literally could do it almost one part at a time. So it makes life a lot easier. Inventories are less. But again, when you get into these type of applications, there is a lot of integration going on, because what we're seeing here is relatively simple integration, because generally we're just pointing the blown ions that you see or the flame treaters that you see above. So they're stationary and the product is moving by. But we do have some of these where the products are more three-dimensional in nature and a little more challenging to treat. So again, direct to print, labeling, wood veneers, things such as that. These are common applications that we're seeing right now, and there's a lot of integration involved. Moving these, especially with the wood veneers, some of these lines are very long and do a lot of different things to that part before it reaches completion. So again, this is just the plasma is just one portion of that that application, and integration is definitely needed. This is just some more applications for plastics and folder gluers. We've gotten recently into a lot of folding gluing applications for boxes and different types of containers, and these are highly integrated parts. If you've ever seen a folder gluer in operation, you can tell that there's a lot of moving parts there. You have a person there, or more than one person in multiple cases, running those machines, because they're very complicated. But again, bonding applications, plastics, folder gluers, these are things where integration is highly important. I believe this. Yeah.
Yep, this will be another video, so let me call that up.
The project was consuming more labor than we had planned, and given the national labor shortage, we decided to pursue innovative ideas in automation. We conceived the idea of using plasma treating to replace the adhesive promoter with the goal of doing it all within the molding cycle. However, the side of the part which needed promoting was facing the cavity side of the tool. Thus, we had to develop an end-of-arm tool that flipped the part over, discarded the runner, plasma treated the parts, and ultimately cavity separate them as well.
Particular application also demonstrates something that we struggle with from time to time, and that's whether or not we should move the part around the plasma or the plasma around the part. In this case, it made more sense to move the part around the plasma, which was stationary. But this was another automotive application with a customer that allowed us to do a presentation along the subject, as well as showing the videos. and they were able to save some money on labor and reallocate that labor to other portions of their plant. So again, another application where the plasma was pretty simple to show that it worked. It just took us a little bit of work with an integrator to put this in place to make sure that the customer got what they were looking for. So what surfaces need plasma and flame treating? Some quick information about adhesive basics. We talk about this slide in most of our webinars. There's two forces in play here, the cohesive force and the adhesive force. It is the adhesion force that we want to increase. That cohesive force is what holds the bonds of the liquid or the adhesive or the coating or the glue or the paint, and it's holding the different molecules together. It's that adhesive force, that blue force that you see on the surface connecting to that liquid that is important. And when you plasma treat or you flame treat a surface, you're increasing the ability of that adhesive force to work. So again, on the right side there, you'll see the treated section and then the untreated section. The liquid in this case, or the paint or the coating or the glue, is going to spread out and level out on the treated side, and it's going to bead up on the untreated side. The example I always use is when you're waxing your car or you're rain-xing your windshield, what you're doing is putting a very low surface energy coating on this there, and that's why the water beads up and rolls off so effectively. Plasma and flame do just the opposite. We're making a very low surface energy area into a high surface energy area, so the water is going to spread out, or the adhesive, or the paint or the coating. So some issues with that surface, the low surface tension. Materials like plastics have a low surface tension. There may be things in there migrating to the surface, flame retardants or other things that might be in the plastic that are going to affect that. We're working with a company actually in North Carolina that was doing a direct to print on a product, and they could not figure out what was going on. They were treating it with flame, they were treating it with plasma, and they just were not getting consistent results. And we found out that the plastic formulation they were getting had a component in there they didn't know was there, and it was migrating to the surface. And as soon as they were able to get some parts that did not have that additive, the problem went away. So you'll see that occasionally. Temperature can also affect it. Light and other mechanical stresses can affect that bond, and all of these things make for a very hydrophobic surface. And these are hard to bond to. So our job with plasma and flame is to make that a hydrophilic surface and get a better bond. So this is what plasma is actually doing to the surface. There's three things. We do some cleaning. Now, the cleaning is usually the organics that might be on the surface. Inorganic impurities are a little harder to clean. The organics generally just go off as water vapor and CO2. But the inorganic, sometimes you can burn off with flame, sometimes you can't, sometimes you can burn them off with plasma. This generally takes longer cycle times than we have, so there may be a cleaning step prior to the plasma treat, but there is some cleaning going on. And in many applications, we don't need to clean the surface at all prior to the plasma because the plasma does enough cleaning to get the impurities off the surface. The second thing that it does is micro etch that surface. So on the left-hand side, on the dirty side of that plastic that you can see, as it goes into the plasma, is very dirty. It's also flat. And as it goes through the plasma, it's going to micro etch that surface. Now, this is on the nanometer scale, so you can't see it with the naked eye, but it is adding 20 to 30% more surface area with which to bond to. So when I'm printing on something or I'm bonding two things together, excuse me, the most important thing is the cleanliness of the surface energy on the surface, and the amount of surface area I have to deal with. And so micro etching the surface is an important part of changing that surface to give you more usable area for that adhesive or that ink to bond to. The most important thing the plasma does is functionalize the surface. Sometimes this is called activation. We're adding polar groups to the surface, to the outermost molecular layers. That is what's increasing that surface energy. If you see an increase in dyne level, or if you see a decrease in the contact angle, and you're looking for those polar groups are what's changing those energy levels. And most of the time, not all the time, but most of the time, when you increase the surface energy, you're going to also increase your ability to bond to that surface. Sorry, I had to take a drink of water there. My throat is dry. I apologize. This is the treatments that we have at Enercon. And this is another reason why it's very helpful to have integration partners because we get involved in so many different applications. No one that I'm aware of has all of these different technologies in one offering as Enercon does. So on the atmospheric plasmas, we have all of our air plasmas. That can be a corona type system, which you're just using the air that's above the film that you're treating. We also have forced air applications with the blown arc and the blown ion. But as well as the air plasmas, we also have gas plasmas. So we have the flame systems, gases with the gases like natural gas and propane. We also have variable chemistry plasmas where we can put different gases other than just forced air, compressed air through our system to get different surface, again, different species on the surface that will change the way it reacts to, say, an adhesive or an ink. But this allows us to do a lot of things. This allows us to look at someone's application and decide what is the best technology for that application rather than looking at the technologies that we have necessarily and saying, we can make a blown arc work in this application, or maybe a blown ion, where maybe flame is actually the best source to treat that part. So again, this is the range of treatments that we have at Enercon. So again, we have multiple ways to help the customer. Also with the blown ion, we have several different nozzles to choose from. The ones that we're showing here are the quad ports and the 45 and the 90 degrees. You saw the 45-degree port in that video. We have 90-degree vertical multi-ports, 2 discharges, 4 discharges. We can make specialty ports. We can make extended nozzles. There's a lot of things that we can do. So if you have an application that's going to require something special, we can usually help you with that and make prototypes and work with you on that. So again, another area where integration and working with an integrator will help us get the best results for the part. Sometimes the standard offering is not the best offering, and we need to work together to figure that out. This is the multi-port design that we have. I mentioned we saw the 500 in the video. It's a blown ion 500. It's a 6-port design. So basically the 6 versions of the 125. The 125 is a 500-watt unit. So this is a 3-kilowatt unit. We've recently launched the 250, which is a 1-inch treater. So if you're not familiar with our numbering system, 250 means it's going to treat 25.0 millimeters. The 500 is going to treat 50.0 millimeters. The 125 is going to treat 12.5 millimeters. But so this is the newest offering that we have. Very good for treating a 1-inch path in robotic applications. We are working with a number of integrators already with the 250 because it's just an easier way to treat a 1-inch path than using 2 single heads or a dual head 125. So again, it's just easier integration. But it's still, programming a 6-axis robot, building the cell, putting the safety features in that you need. So that's where we work with our integrated partners. On the flame side, this shows some of our newer designs. Generally speaking, before we had just straight burners, pencil burners, round burners. Now we have got angled burners or 2-sided burners, V-shaped burners or L-shaped burners. This allows us to treat multiple dimensions with one system. They generally do have 2 igniters on there. We want to make sure that every section of that is ignited. In that picture right now, we're not seeing but 1 igniter, but we generally put 2 on there. And that's how we monitor whether or not the flame is working properly and make sure that we're getting good treatment. But these are some specialty heads. And again, we're working on a new specialty head as we speak. So we don't have all of these solutions right now, but we can work with your team and your application and try to figure out the best, best setup for what you're trying to do. why system integration and automation are needed. And I've brought this up a couple of times, but we just want to make the point again. Providing the treatment technology to improve adhesion is relatively easy. We do lab testing every week. We do on-site testing every week. And proving that we can do something with plasma or flame is generally very simple. I would say 90 to 95% of the time we are improving the surface energy, and in almost all of those cases, increasing that surface energy is going to help the customer. Then we run into, okay, how they've been doing it a certain way for a while. How do we break into that line and change what they're doing and make it efficient and make it seamless to the customer? So again, showing that we can help is easy. Actually breaking into the line and changing the way they're doing business today is the more complicated part. So that solution may be complex. Some of them are easy, some of them are hard. In most cases, some form of the following is needed. We need product handling. How's the part going to get to the plasma? How's the plasma going to get to the part? Does the head need to move? What kind of safety guards do we need? Do we need light curtains? Do we need other disconnects and things to be in place properly so that you can safely treat a part, so that a worker that has to load and unload is safe? So all of these things are what we have to deal with, and all of these things are where we need our integration partners. The integrated cell needs to be worked properly. The robotics need to be done. The indexing systems, the conveyors, whatever those things are, those are the things that have moved outside of our wheelhouse and are into our partner's wheelhouse. So implementing automation, move the part, the head, or both. Again, in every application is different. Some are very simple. You're treating a print line on a wiring cable. You're treating down at the bottom middle there. We're treating an electrical conducting or connector, and it's relatively simple. We can treat millions of those at a time. Sometimes the bottle is just going down a conveyor, and all we have to do is treat it. Whether or not it's spinning or not makes dual head or maybe 4 heads might be needed, depending on whether or not that bottle is treating. But sometimes we have to move the part around the plasma, or we have to move the plasma around the part. We can't simply just point the treatment at it. So that's where the challenge comes into play. We do some conveyors and some fixed head setups at Enercon, but once you get into robotics, we generally pass that on to the integrator. This is an example of an indexing station. In this case, they're making toothbrushes and printing on toothbrushes. And so it goes around the table, and one area will put the bristles in, another area will paint the side, or another area will coat the side, another area will print the logo on it. So this is a multiple station here where multiple things are happening. You can see the light curtains in front there that need to be formatted properly. All of our systems are ready to handle all of this input. We just have to, of course, have someone willing to put this into place to help the customer. Again, you see videos on our websites all the time of us treating dashboards and electrical parts. These might be XY robots, XYZ robots, 6-axis robots, multiple robots in some applications. Again, these are ideal for complex shapes and makes the world a lot easier when you can manage that distance from the surface. With plasma, one of the things I haven't really mentioned yet is plasma, the distance and the speed are critical to get a repeatable surface. With flame, speed is critical to getting a consistent surface. So those are things, that's why we use robotics. Some of these, we get calls all the time. Can we treat this by hand? Can we do this by hand? And in some cases you can, but in most cases you're going to get inconsistent treatment, just like you would if you're using wet chemistry and you've got somebody wiping something down or adding a primer to it. You're just going to get inconsistent treatment because a person is doing it, and we do things differently every single time. But a robot is going to go the same speed, it's going to be in the same position every time, and we're going to be able to we're going to be able to consistently offer you a part. If I know how the part is coming into our system, I can predict how it is going out, and that's how you improve quality. How Enercon equipment and support makes it easy for integrators. Thanks, Mark. We got a little off on that. So this is the systems that we generally use in an integrated system, and that is a remote transformer or a remote ignition setup. So on the left there, you see the blown ion 125 cabinet, but it has a remote transformer. So we've taken the transformer out of that cabinet, and then it's connected to whether it's the blown arc or the blown ion. The 250, the 500, or the 750, they all have a very similar look to them. All of these parts are going to be there. And what this does is allows it easier for a robotic or a conveyor integration so that you do not have to have the power supply as close to the actual, in this case, let's take a robot. Obviously, if you have a large robotic cell, you need some space. You need to be able to run those cables a decent distance. And the remote transformer option in that case makes these things very easy. The igniter cable that's going through the from the flame system on the right is a very similar type application. There's only so far we can run that ignition cable. So we can remove that portion of the system from our control panel, and that control panel can be further away. And again, with network controls or integrated controls, you can operate that from, that portion doesn't even need to be close to the system. It just needs to be within the 20 or 40 or 60 foot. There's different applications here of the igniter system. So again, this allows us for flexibility when you're putting the cells together to where everything needs to be. Sometimes space is at a premium in those cells, or I say sometimes, it's almost always a premium in these cells. This is something that's already programmed into our plasma systems. Again, this is a dual head 125 on the top right there, and there are connections in the back. And then from the touchscreen, you can use it remotely. You can use a network control, or you can use it in local. So again, it's very easy to switch back and forth between these two. So if you need to run some testing, you can switch over to the local testing and then run it, but then you can go to a remote operation or a network control. And all of these are right there built into our system. These are the controls that we already have that are in the system. We have automated controls for signal lights, foot pedals, things like that, external indicators for stacked lights or audible alarms, external controls, stop and start and stop, enable, disable. All of those things are already built in. We use an Ethernet connection. Modbus TCP is our standard protocol for the Ethernet. We do have communication bridges that we can use if you're using Profibus or some other type of communication, so we can work with those. But this is already built into all of our machines. We also have the documentation and support that you're going to need to make this easy, to make your life easier. We have quick start guides, so it tells you everything you're going to have to use and everything you're going to need to operate with one of our systems. Detailed manuals. We have cable management systems, the best practices there. If you're moving around one of our plasma systems or our flame systems, there's some things that we need to be aware of in cable management to make sure that we don't have issues with those later. Utility exhaust requirements, safety provisions, startup assistance. We have 24-hour a day, 7-day-a-week support, and we have the ability to quickly ship all of our parts from our Germantown, Wisconsin location. So again, these are all things that will make your life easier. So how can we grow business with Enercon? Or how can you grow business with Enercon? We are looking to start a network of qualified Enercon integrators. Now, we do have several of these, but everyone has their own, as an integrator, you have your specialties, the things you're best at, the type of projects you normally get, and you also have an area which you generally cover. Whereas Enercon, we work with customers in all of North America, Central America, South America, Europe, a little bit less in Asia, but again, we are looking to grow this business and make sure that we have qualified integrators in all of these areas that are familiar with our products, familiar with the type of support that we can offer, and bring this bring this on board to help both your business and our business thrive. Again, it's easy for us to show that we help the customer. What's more difficult is for us to actually implement that without an integrator. So again, we're looking for your support there. And you can also bring us your next treatment project. So if you have an application where you have a plasma or a flame, we'll be more than willing to work with you on that. So again, make this a mutually beneficial relationship. We're putting this together now. So we need some of your information, again, where you're comfortable, what projects you generally work on, which areas of the country or the world that you work in. So let's put that together, and hopefully we can help each other grow some business.
All right, thanks, Wilson, for sharing those insights. Let's take a quick review of the key concepts presented today before we get to our audience's questions. We found that automotive, product decorating, window and door assembly applications are among the most active in the industry right now, requiring integration. Plasma and flame increase surface energy and wettability to promote bonding with inks, adhesives, and coatings. And some of the benefits of working with Enercon include that support that you talked about from project conception throughout the life of the customer's line. And along with our integration-ready technology and application expertise, that ensures projects are under budget and on time for the integrator partners. As we mentioned, Enercon is looking for more qualified integration partners. Please contact Wilson to learn more and find out how to get recommended to potential buyers looking for integrators for their plasma and flame surface treating applications. You've got Wilson's contact information there. Feel free to reach out to him directly if you are so inclined. And first question we've got, it's actually a comment. Wilson, thank you for the insights. We're an integrator and weren't aware of many of these applications. Is it possible to do a custom presentation for our team?
Well, of course we can. So just email me or give me a call on the number below, and we will set that up. We can get all of your groups involved, and we can do a presentation very similar to this, or we can customize that presentation for what you're looking for.
Great. Next question is, which surface treating technologies require exhaust?
Okay, that's a good one. We always recommend exhaust. Let me put it that way first. With plasma, what you're dealing with mostly is NOx. It's almost all NO2, actually. 99% of it or so is NO2 coming off of the systems. And it's less than 1% of the air going into the system. So if one of our systems is using, say, 1.5 cubic feet a minute of air, again, less than 1% of that comes out as NOx. Now, NOx is heavier than air. It's going to fall to the ground. It has a half-life of about 30 minutes before it starts breaking up on its own. So in a lot of large areas, I've witnessed almost no venting. Big automotive plants, big wire and cable companies will have plasma systems all over the place, and I've never seen them ventilated. Again, we always recommend it. The downside of not doing it is if you sit there and breathe it for a long period of time, you're basically going to get a sore throat. It's going to dry out your respiratory system. But again, if you're in a lab, you're going to want to have a hood. You're going to have to put that exhaust in some place where you can remove that from the area, because again, a smaller, like my office or one of our labs in Wisconsin, we always ventilate that because it is a smaller area. With flame, you can get a little bit more complicated because you never know what you're burning off with flame. There's going to be coatings or things on there that might just be burning off and changing in the atmosphere. So you definitely want to ventilate that off unless you know what's on the surface. So again, it's always something we recommend. Sometimes it's practical to do, sometimes it's not practical, but it's something that we can discuss.
Thanks for that, Wilson. And one more question. How do you know which surface treating solution is going to work best for an application?
We roll the dice. No, I'm kidding. We test these things. So we have a lab in Wisconsin, in Germantown, in our new facility, and we have systems, consignment systems. We have reps with systems. We have regional managers with systems. we test everything. Unless we know that it's going to work, say a window and door application where we're treating a PVC frame and we know that works and we know what speeds work, or it's a wire and cable application where we're printing and we know what the material is and we know the treatment speeds. Those may not require testing, but if it's anything new, we always test it. We do not sell systems that we haven't tested and proven out, prior to installation. So again, contact me. We'll get you an RMA set up to bring samples into our lab. You can bring samples into our lab. You're always welcome to do that, or we can work on how to get a unit to your facility. There's just certain applications sometimes that they don't make any sense to bring into the lab because it doesn't do any good. We have to do it on your line. So again, we can work with you on those.
All right, thank you, Wilson, and thanks to our audience today. This will conclude today's webinar. Please, again, feel free to reach out directly to Wilson if you have any additional questions. Also, if you found this webinar informative or have ideas for future topics, please reach out to us and let us know as well. Thank you again for everyone participating, and that will conclude today's webinar. Have a great day.